Okay, how many people here use Emacs? Sorry, this talks about Vim. So, so I'm the maintainer of the closure indentation and syntax highlighting plugin, which is built into Vim, and you can also install it as well. So this is a talk about an algorithm I developed to improve the performance of the indentation. So, just a reminder, here's an example function. If we take the math power line, right, and we press the enter key, we want that to be pretty instantaneous and also figure out where it should go, right? So this is indentation. So how can we do this efficiently? The previous algorithm relied on syntax highlighting to figure this out, which is notoriously slow within Vim and very buggy too. So my solution here was to try and build a special purpose closure reader inside of Vim. There are some constraints, though, that we have to operate within. Unfortunately, VimScript, the scripting language of Vim, is extremely slow. In fact, it is so slow that loop iterations are slower than regex searching the entire file. We also have Vim9 script and Lua available, Lua being the scripting language for NeoVim. However, due to just limitations of how libraries get merged into Vim, it has to be in the old, slower Vim script. But I will provide faster alternatives as well. Also, the algorithm has to be stateless. It can't track state between lines. It runs per line, always. And we also cannot assume that all code within the file is valid. This is due to Vim not really having structural editing by default, so a lot of people won't be using it. So if we look at a regular reader, right, we read left to right, and we assume we're at the top level. So it's fairly straightforward to figure this out. However, we can't read from the top of the file because we'd have to do that for every single line, and the larger the file, the slower it will get. And also, as I've mentioned, iterations are extremely slow. So we instead we perform the indentation starting from the line you are currently operating on, and we work our way backwards and up the tree. So the base algorithm that we're going to use, we're going to walk through it. So here's the example from before. I've altered line 7 to add an extra line there to make the example a bit more interesting. We don't need to know too much about the context yet. I'll highlight bits as we go, so I'll just color it out. So we're going to keep track of several things. One being a list of tokens and where they're found. The line we are also currently on, so we're starting on 9. And also we have a list of tokens down at the bottom, which are the ones we're looking for. So to start this, we just decrement the line counter. We look at line 8, and we see one of those tokens, which is the closing square bracket. So we add that to our list of tokens. Next, we'll go to the next line, line 7. This time we find 3 more. Here we see a quirk of this, that we are reading backwards, so we are inserting into that list in the reverse order. So we can see we've got the closing square bracket, and then the open square bracket, and then the opening round bracket, and so on. We then perform a compaction operation. So these two cancel each other out because we've started with a close and now we're opening. So we can remove those from our list. It's not actually a list in the actual implementation because that would be inefficient to constantly remove and insert these in that place. So I've got to go a bit quicker now. So we go to the next line. Oh, sorry, on that we've got a first opening one, so we're done. Right, and that gives us a base indentation, which is the index, the column index. We also then apply a special rule here for a list, because we know we're in a list now. So the first symbol is fn, so we're in a function, and there's a special rule for that, which is +2. So our indentation is a base indentation of 16 plus 2, which is the function indentation, which gives us the correct indentation. So there's some bits of tricky syntax within here. There's escape characters, which I think probably figure out why those might be a problem. I'll skip over this for time. We've also got dealing with semicolon comments, which are tricky because they're not actually structural. They operate to the end of a line, and since we're reading backwards, that screws things up a bit. So there is a separate algorithm for that, which I'll just walk through here quickly. So close, add as before, and because we've seen a semicolon in there, everything before it on the same line we just remove from the list and keep going. Multi-line strings, I really do not have time for these at all, so we're going to skip over them. They are a massive pain. So anyway, there is a solution for it. So the results of this, you can see we got significantly faster. With Vim 9 script, the newer version of Vim script, we see we get like a 10x plus improvement. With keeping it within the old Vim script, we get like a 2 to 3 times performance improvement. Yeah, sorry, I'm done. And then there's some other benefits there. And if you want to find out some more or ask me questions, here's some links. Thank you.